So the recording feature is now open, and this is the session for ACE College Algebra on our snowpocalypse. No, it's not snowpocalypse. It's wind chill apocalypse day, January 30th. Section 9.5, we're going to look at examples 2 and 3. This recording will be posted to Schoology in case you want to rewatch it or if you weren't able to attend the session. So here we go. We've got example 2. Fun, fun, fun. Example 2's got a little bit different graph of f of x and g of x. I have a lot of things on my screen, so I'm going to slide some things over so we can see this. But does this particular problem, does it state which function is f of x and which function is g of x? That has always bothered me because it didn't in the original documentation. So we're going to work under the assumption, as we did in the last problem, that f of x is the dashed part. So it might be good to label that. And g of x is the solid part. And I'm going to double check the chat because I think we got some people coming in and the mics are kind of loud. And I'm going to just make sure that everybody's muted that's in. Mute all. Looks like I got us muted. Okay, so we have got an f of x and a g of x. So our first task here is to find the values of x so that f of x is increasing. So we're going to look along this dashed line and look for behavior where any y value is larger than the y value that comes before it, because that is the calculus definition that we're going to operate on under with increasing. And we notice that we're not going to have any increasing behavior until we're at least down in this area here, right, where the x value is 3. So we're going to start there at 3. And we know that we're going to go all the way to infinity. We're going to go ahead and obey the arrow, right? The arrow means something now. Now, as we said before, how do we treat the 3? We're going to go ahead and use the new sort of directive with this curriculum that says we can increase and decrease at endpoints. All right, I will be pretty lenient with that when I grade the exams. All right, I think again, Mr. Keller is going to be pretty lenient when he's put up the Schoology, but if you want to make sure that you don't run into any issues, I would go ahead and include the endpoints on those. Don't include the endpoint for infinity, of course. We're going to do the same thing for when f of x is decreasing, and we look and we see that that's going to happen very early on between -9 and negative 6, sorry. But we want to be awfully careful that we do not include the -9 because we don't have an open, or we don't have a closed interval, we don't have to have a domain value there anyway, but we can include the -6. And obviously the constant is going to occur between -6 and -1, and both of those are certainly welcome to be included. So hopefully that makes sense. That's pretty easy. Now we're going to move to the second part and figure out what are the values of x so that the function is less than 0. Well, this function would be less than 0 when it lies below the x-axis. And that initially is going to occur somewhere around in here, but we don't want to get fooled by just assuming that that's a nice value of x. So we want to kind of think about this a little bit. And in thinking about this, I might go all the way up to this point here and see if I can get a handle on what the slope is doing. Seems like it's going down 3 blocks over 1 block, down 3 blocks over 1 block. So I would say that we are fine to include that particular point. So we're going to include the -1. Now I'm going to say something that I hope it doesn't confuse you. I had a student come to me and ask about these dashed lines. And they were confusing them with maybe the dashed lines that you may have learned in Algebra 1 that weren't really a part of the graph, but like you would shade above and below. This dashed line is not meant to be that type of graph. This graph is only dashed so that you can tell the difference between it and the solid one. Otherwise, we would have to color them in, and I certainly could go through them and color them because I did copy your papers in color copier, but it was going to be a lot more work to make that happen since this is the way that it arrived to me. So don't get any confusion set in your mind about what this dashed graph means. It's supposed to be connected, solid, continuous. It's just differentiated. So we're going to take this guy all the way to, well, do we take it to infinity? The answer is no, because this graph is going to eventually pop back above the x-axis. We would like to figure out when that happens. So we could trace this back here to this point, see if we can fashion a slope, maybe up 1 over 2. Does that look possible? Up 1 over 2. I would say that that's the slope, up 1 over 2, up 1 over 2. So by the time we get back to the x-axis, we're going to be at 15. So that's where we're going to end that function being less than 0. We don't include the 15. We do not include the -1 because we're looking for strictly less than. Okay. Now things get a little bit more interesting with part E. Find the values such that f and g multiply and are less than 0. Well, what do you know about two things that you multiply and get a less than 0 result? That would mean that f and g have different signs, right? One will be positive, one will be negative, or vice versa. Yep, perfect. And then we were going to go ahead and just look at the graph and see when this is happening. So basically, you're just looking for intervals where one graph is maybe above the x-axis and one graph is below the x-axis. And boy, does that happen like immediately, right? But be careful, because you don't want to say anything about this part of the graph, because we don't know what's going on with f of x in that realm. Remember, we can only start analyzing this when we get to -9. All right, so it's perfectly acceptable to start this at -9, open interval, because we don't have the value in our domain for f. But you can keep going until we no longer have opposite signs, which looks like it's somewhere right around in this area. Now, can we just assume that to be -4.5? Probably, it looks like it is, but just to double check, you can look at this slope and you can see that this slope goes up 1, 2, 3, 4 over 1, 2, 3. Did I count that right? Up 4 over 3? We do not want to assume that to be -4.5, do we? It's probably pretty darn close, but I don't think it's meant to be. Or did I count this wrong? Up, I'm going to try this again, guys. Up 1, 2, 3, 4. And then it looks like it's over 1, 2, 3. Yeah, see, I'm a little worried about that. That means our equation, I'm writing over to the side, is 4/3 x. And eventually, if we keep going up 1, 2, 3, 4 over 1, 2, 3, the y-intercept would have been 6, would it not? So you have to put together an equation for that piece, and then we want to figure out where this piece crosses the x-axis, so you let the y or the whole thing be 0. And if you solve for this, 4/3 x would equal -6. Multiply both sides by 3/4, and we're going to get surprised here, guys. We're going to get -18/4, or if you want to reduce that, -9/2. Oh, so it is -4.5. It still is -4.5, despite that doubt that we had by counting up and counting over. Okay, so I do this only for the reason that you might see something that you think might be halfway between a couple of points, but this is the best way to verify without any doubt that you're going to be dealing with that right value along the x-axis. So this is where we want to end this particular interval at -4.5, right? And we will open parenthesis, because when this guy is equal to 0, that does not mean that we'll have a negative answer anymore. Now we're going to go through the graph a little bit, see they're both positive, and then, oh, by the time we get to looks like by the time we get to, I'm going to erase some stuff here. By the time we get to 1, it seems like we are now dealing with opposite signs again. So let's just join this right up with open interval 1, and then we are going to be opposite signs until, well, it looks like it would be about 6, because that's when the G graph decides it's going to be 0. Now, is there any other instance when we will be opposite signs? And the answer is yes, just for a teeny tiny bit, starting at what looks to be 10.5. Now, can we trust that that's 10.5? Well, if we count up 2 over 1, I am very certain that using 10.5 is going to be safe, because this had a little bit more trusted slope progression of going up 2 units over 1 unit. So we're going to end this at 10.5. And where did we say, or I'm sorry, we're going to begin the interval at 10.5. And I think we're only going to go to 11, aren't we? So I'll just have another union here, just kind of continue it. 10.5. How do you want to write that, guys? It really makes no difference. I'll use 21 halves to be consistent with this, but I don't care if you mix and match decimals and mixed fractions. Now, one thing I think that is important is when we get to the 11, I think we want to put a bracket there. Now, is that right? Let's double check. When we are at 11, the F and the G are both defined, so it certainly would be a value that we would consider including. So that would be your final answer for part E. Okay. Part F is somewhat similar, except now you want to find the intervals over which the two functions have the same sign. The same sign is going to be your positive 0. Now, we can start that immediately at this value that we saw, -4.5 or -9 halves. We will not include him because that's when we were equal to 0 for our G function. And we are going to be the same sign all the way until we get to this 1. Okay? And then from that 1, we're opposite signs for quite some time, right? Until we get to 6. Now, when we get to 6, both graphs are below the x-axis and will stay that way until we get to that 10.5 or 21 over 2 that we talked about before. And to my knowledge, I think that's where we would initially stop. And what's nice is that even though this graph of the F keeps going up higher and higher and higher, and we're like, oh no, we're going to be back to a positive, the G stops. So we're not going to analyze him anymore. So does that make sense? Okay, I'm going to double check. I'm going to look at the chat and see, because some people have talked about, did I mess some things up? Golly, okay, let's go. Max, B is not finished. Is there more to B? F of X is decreasing. What did I mess up on? We got -9 to -6. Yeah, why did I not finish that? It's like, is this not obvious decreasing for some reason? I'm not so sure why I overlooked that. Let's take a look at them. -1 to +3. And I think we can include the -1 in the +3, right? That is a huge interval of decreasing that I just overlooked. So that takes care of B. And then that takes care of what Colin and Jackson were talking about. So good. You guys kind of took care of that in the chat. So looks pretty good. Looks pretty good. So is everybody okay? A through F look pretty solid now? If not, just say something in the chat. If you don't say anything, then I'm assuming that we're good to go. So we can just do our third example, which is our last one. So, okay. Okie doke. So let's go ahead and look at our final example 3 here. this is going to use a completely different function, h of x. So got this piecewise function. It's actually got some unusual parts kind of meshed into it. All right. So hold on. Martin says D should be 1, not -1. F of x is less than 0. F of x is less than 0. What the heck? Gosh, you guys, you got to watch me like a hawk. Change this. This should be a 1. Yeah, f of x starts below the x-axis at +1. So, Kariatu, I am recording this and I will post it to Schoology later on in the afternoon. It takes a long time to process, but if you want to catch up where we were, you can certainly watch the beginning of it. We just started with example 2. Basically, all you missed is me make a bunch of mistakes on part B and D. Okay, let's go ahead and start looking at example 3. Example 3 starts off with a doozy. It says, identify the equation of h of x. So we know that this is going to be a piecewise function. So we're going to start right away writing h of x, preferably somewhere in the middle of the box. And you can probably look and guess, and if you want to type this into the chat, I'll open it up. How many pieces do you think will exist in our piecewise function? I'll give you a second to think and enter that number into the chat. How many pieces will be in the piecewise function? Three, trace. Yes, I like it. Trois. So that's what we're going to go with. So there's going to be 3 pieces. So I'll make my little brace pretty large. First piece is probably the easiest piece because we're talking about a line. How you want to find the equation of this line, there's a lot of ways to do it. All of them revolve around you being able to figure out that the slope of that line is indeed 2. So you could go ahead and call this 2 times x. Now here's a trick if you don't want to take those 2 points and use the point slope formula. What you could do is just continue to apply that slope if the line were to continue, and lo and behold, you would come to the realization that the y-intercept is 7. I think that's a little faster than using the equation or the point slope formula. Now you only have that luxury because you were given the graph. So unless somebody wants to contradict this, I would say that we're safe in saying 2x plus 7 would be the equation of that top piece. That top piece is defined starting at -6 and continues to be defined until we get to -3, but we will not include the -3. Remember our conversation from yesterday. I would strongly urge you to use inequality notation for your piecewise function graphs. All right, now things are going to be a little bit more challenging. I'm going to erase the stuff that I've written on the graph, kind of focus in on this piece here. Is everybody pretty confident about what you think the parent graph is? Don't worry about typing it into the chat because it's kind of tough to type in. But it would be the square root of x, would it not? In fact, if it were flipped the right way, and maybe I can do that. Maybe I can flip this the right way. I'm just going to put like dash lines. Then it looks like the square root of x. Because it's flipped upside down, we all know that that means there is a negative sign in front of the square root. That takes care of the flip, right? I don't believe that any stretching is being done. Would you agree? Because we got our up 1 over 1, and then it's like, you know, over 1, 2, 3, 4, up 2, like it normally is supposed to be. So that means that the coefficient in front just remains like a 1, or in this case, -1. However, this thing has been shifted, both horizontally and vertically. Normally, it would have been located here, but the horizontal shift has moved it 3 units to the left. So what would we put inside after the x? If you want to put this in the chat, you could. I think Blake's already got the result for us, which is awesome. Typed it in really well. That would be an x plus 3, right? Then we could close off our absolute value. And then the vertical shift looks like we've undergone a +1. So we'll type that. And it's real important that we put the +1 after or outside of the square root. All right. That's why Blake did a good job of using those parentheses and brackets. Okay, this is defined starting at 3 and going all the way to, maybe I better erase this to make sure I can see what's happening. Yep, it looks like it goes all the way to 1, and it will include the 1. So we're going to put a less than or equal to there. And how about I put a negative in front of that 3? That'd be nice too, wouldn't it? Thanks, Martin. All right, so we've taken care of that part. Once again, I'm going to erase everything. And now we get to do the parabola. This parabola is a parent graph of x, or the parent graph would have been x squared, right? Now, does this have any kind of weird multiplier in front of it, or does it kind of use our traditional over 1, down 1, over 2, down 4? Looks like it does. Looks like this is just a normal x squared, but it will have a negative in front to accommodate the fact that it is flipped upside down. But I don't want to put the square around it yet. Why not? Because there has been a horizontal shift. The vertex, normally at the origin, looks like it's been shifted over 3 units to the right. So we would put an x minus 3 there. Now we can square. And then the vertex is shifted up 1, 2, 3, 4, 5. So we'll put a +5 there. That looks perfect. We know that this is true starting at 1, but not including it, and then finishing it up at 5. Right? So what Trevor had written in the chat is 100% correct. Okay, you guys, this is a good skill. It really is. Piecewise functions, in the past several years, my calculus students have been very fearful over them. And the reason is that their college algebra course, unlike yours, did not give them a lot of exposure to them. I think you guys are getting more and more used to them, and they'll just be just old hat by the time that you guys encounter them. So nice. All right, I will say that part A of this problem is probably more time consuming than the other parts combined. It takes a lot to kind of generate that equation. All right, now, because we did this equation as a question, I would say to you all, for the subsequent problems, you might want to consult the graph more readily than you would consult the equation in case the equation's wrong, right? We talked about that. Now, I know that this equation's right, and I'm going to be honest, it's not because I did it, because I also have 3 pair of eyes watching me, and you guys have been very, very good about pointing my mistakes out. In fact, I think you have fun doing that. In fact, somebody said that they have a board. They have a board that has a tally of all the mistakes I'm going to make, and you have a pool going by the end of the year. The over-under is 107. Is that right? Is that true? Okay, I'm just making that up, but that'd be fun, wouldn't it? Okay, for part B, identify the domain of h of x. The domain of h of x would be what values of x that we are allowed to have. So you just start at this -6 that you see. We will include it. I'm okay using interval notation now, and I know that I have to stop and pause at -3, don't I? Can't go beyond -3 because he's not defined. So I'll just exclude him, and that's pretty much how you exclude a value. You just stop your interval and start it right back up again. And then I can take this all the way to 1. Even though there's an open circle here, I'm okay. I've got 1 included at some stage, so I'm going to keep it going, and I can keep this going until this guy decides to stop, and that's at 5, and that would be inclusive. So there would be your domain. And you guys are also getting extremely good at typing in domain into Schoology. Identify the range. We are going to start at the very bottom, which is at -5 inclusively. We can take this all the way up to 1, and unfortunately, I don't have a 1 here. Darn it. I don't have 1 included here. Darn it. But whew, we got it included there. So we can just keep this going all the way up to 5. And I think that this range is -5 to 5, right? Would you guys agree? Okay. Good things going on in the chat. And definitely point out if you guys see a mistake, but I think my B and C are correct. I'm gonna make this 5 look a little bit better, but I think we're good to go. All right, got to really watch out for these open circles. They can get you into trouble. You saw how it got me into trouble on one of our recent homework assignments. Okay, now we've got part D, which is a little different. It's now saying, okay, we've got this brand new function in town called P of X. It's an absolute value function. We want to figure out, when does this function equal H of X? Okay. Now, correct me if I'm wrong, but I think I remember taking functions P of X and set them equal to other functions, H of X, or whatever they were called. But when that happened, we did not have a piecewise function. So one thing that you could do is you could take this P of X and you could write an equation where you set it equal to this yellow expression and solve, and then write another equation, set it equal to this green expression and solve, and then write a third equation and set it equal to this blue equation and solve, and then make sure that any answers that you got from each of those 3 equations only lie in between these intervals for their respective functions. Does that look like fun? Anybody want to say that that's fun in the chat? Or you can just say no. Is that how you? Nope. Martin says nope. That's obviously not a good way to do this. What do you think we should do to this function P of X to make this easier? Give you a hint. I'm kind of erasing some stuff over here to get something ready. So what would you do? What would we want to do with the P of X while the H of X is right here in front of us? Graph it. Exactly. I think that that's your best bet. It's not a difficult thing to sketch. If by some chance we didn't have the graph of H of X already there, then maybe we do this yellow, green, blue thing, which is something that you probably would be able to do. I am a little worried about the green and the blue because we haven't talked about how to solve absolute values with radicals and absolute values with other quadratics. So if we graph this absolute value, what we know is that it would normally be a V positioned at the origin, but that minus is going to make it go upside down. But then the +1 is going to make it shift to the left 1 unit, and the +3 is going to shift it up to the right. So am I correct in getting rid of my highlighter, because that's not a good pen to use? Let's use some different color. I'm going to use a purple so that this will stand out. But guys, am I right in saying that the vertex should be here at -1, 3? And we would have a slope that would be of -1 and +1. If you're very careful, you could probably draw this free-handed. But I know that you all now have those wonderful homework hotline rulers that are so cool and fun to use. Okay, so basically I want to know, when do these 2 graphs intersect each other? What do you guys think? Trevor says they don't. Is Trevor right? I think I'm going to agree. Guys, I think this is no solution. Now, it asks to explain the reasoning, and I guess that would be because P of X crosses H of X or intersects H of X at open points or values that aren't defined. There's a lot of different ways that you can say this, and I'm being a little bit more informal than I want to be. I don't like saying crosses H of X at open points. The best explanation would be intersects H of X at points that aren't defined on H of X. But I've got 2 years to get you guys, 3 years in some cases, to get you guys used to using more formal language like that. okay? I'm going to jot that down just so that it's here, but this is the best explanation. P of x intersects h of x at points that you could say aren't in the domain of h of x, or that h of x is not defined for, or for which h of x is not defined. It's certainly a little bit more mathematical sounding, but the three teachers of the course, we've been, you know, counting things that are a little bit less formal, that are conveying the right meaning. All right. So if we look at part E, identify the values of x where h of x is 0, that would be, and you know what, I don't think we need this p of x anymore, am I right? Nope, take that back. J and K want p of x in there. So I'm reluctant to erase the p of x right now. So maybe we can still see the graph without erasing it. So h of x is equal to 0, and yep, you are right. You guys are already over this. You see -3.5, 2, -3.5, and 2. -3.5 and 2. Notice I'm not going to write them in interval notation. I'll do this instead. Wait, did I say 2? I went -2. Okay, can we trust that that's going to be 3.5? Yes, we can, because of the slope being 2 there. Okay. F, identify where x, for what values of x where h of x is positive. We've been doing a lot of these, so this is getting kind of old hat. I'm just going to go ahead and stick with my decimal. We'll start at 3.5. And this is kind of interesting, guys. You don't want to take this to 2, do you? And the reason is because when you get to -3, we're not defined. So we have to close it off there, union this with -3, and then you can take it on to -2. So that open circle there at the top was really important. This is where we could get in a little bit of trouble, because if we graphed that purple line on top of that open circle and kind of covered it up, we could have missed this part. I kind of wish that this p of x question may have been introduced at the very end of everything, so that wouldn't have happened. I might decide to rearrange this in the future. Any other times when h of x is below the x-axis? I'm sorry, above the x-axis? Yep, from what, 1 to 5? But we don't want to include the 1, do we? So maybe something along these lines would work. Okay. Now we have the opposite. When is h of x below the x-axis? We know that that's going to start at -6. Take that all the way to -3.5, but do not include the -3.5. And I know that I'm scrolling a lot back and forth. If you have the notes in front of you, then you guys can see the graph there all the time. And then we're going to be below the x-axis again from 2 to 1, -2 to 1, I'm sorry. Do not include the -2, but let's do include the 1. But no more times are we going to see h of x below. All right, part H, identify the values for which h of x is less or equal to 0. So that sounds a little bit like what we did in part G, but now we're allowed to include the places where we are on the x-axis. So if we peek at this again, when we get to this -3.5 right here, we can include him. And when we get to that 2, we can include him. So it's basically the same answer that you had for G, except you can put brackets around those two numbers that were formerly in parentheses. All right. I is going to be a lot like F, is it not? Now be careful, because I still don't think there's anything that we're going to be able to do about that -3 situation. We are only going to be able to say that we can include this -3.5 and we can include this 2, but we can't do anything about this -3, nor can we do anything about that 1, because that 1 is not where we were on the x-axis. So basically put brackets around the -3.5 and the -2. So you'd have something that looks like this now. Okay, now we could actually use that P of X graph again, which is again kind of weird. I think this is where I would have probably introduced part D and then J and K, L and M. So when is the P of X greater than the H of X? Well, it looks like that's going to happen between the -6 all the way up to the -3. But do we include the -6? I would say certainly we would, but we do not include the -3 because it's not defined in the H of X value, the H of X function. There probably is another interval. The purple graph is above. Oh, it's going to be above even more afterwards. So after the -3, all the way until we get to, looks like +1, but we don't, or do we want to include the +1? That's a good question. After the -3, do we include the +1? I say yes, we do, because the H of X is defined to be -1 right there. So we're going to be good all the way from -3 to +1 inclusively, but then that is it. That's where we can end our interval. All right, I'll kind of monitor the chat to see if anybody disagrees, but it seems like either you're all asleep or I'm not making any more mistakes. All right. P of X less than H of X. So when is the P graph underneath the H graph? And it doesn't seem like that's going to be very common until we get to this 1. And as that begins to happen, the 1 will not be included because that portion of the graph up here, 1 is not defined, but we would include that all the way to 5. So I say that this has a pretty simple answer. Open 1 to closed 5. Open 1 to closed 5. Okay, and then we finish up with questions just about the graph of H of X. Okay, now what I'm going to do for H of X, increasing, decreasing, I'm going to get rid of my graph of the absolute value now because we don't need it. And I agree with Kadiatu. It's really difficult to see what H of X is doing when you've got this other P of X on top of it. But I think these are two of the easier questions. Why they're at the end, I don't really know. But you can see that H of X increases between -6 and 3, or -3. Remember, we can include endpoints if they're defined, but don't include them if they're not defined. There's a big difference between those two endpoints. Okay, we don't want to include the -3. And then we would continue to increase from open 1 to closed 3. And that takes care of H of X increasing. The decreasing aspect would occur between -3 and +1. Open at -3 because he is not included. Include the 1 because, or not 1, but yeah, I'm sorry, it is 1. Include the 1. It's tough for me to kind of go back and forth. Actually, I would do better off if I just kind of look at my book. It's in front of me. So I will definitely include the +1. And then I want to say that we're going to be decreasing again from closed 3 all the way to 5, and include that 5 as well, right? Why can't we include the -3 for this last one? The reason would be because it's already defined to be an open point. Because it's an open point, we can't classify it as part of that increasing or decreasing interval. All right, we've opened the door to be able to say that we can increase at endpoints or decrease at endpoints, but only if those endpoints are defined, like -6 was, but not at this -3. Or we can't use this endpoint of 1 if we start it and move to the right of it. We could use this endpoint if you were coming in from it from the left, though. I know that kind of seems a little confusing, but that's the way that it's thought of. So, guys, we're done. That was it. That's all that I really wanted to take care of. To be honest, I think that with what little that we did in class, you would have been okay with the homework and subsequently been okay with the quiz. But, you know, especially with me being gone Friday, I just didn't want to take any chances. So that's how things are. We would have taken the quiz today, but obviously that has changed. So the plan would be for Mrs. Ryan to be with you guys on Friday, and you would take the quiz very, very early, beginning of the period. And I just don't see it happening where you guys will be able to get into section 9.6. I kind of wanted her to maybe introduce it, talk about things a little bit, but it just isn't going to happen. If you have your notes packet in front of you, hopefully you do. I'm kind of flipping through it. Page 1 is just all talking about domain and range, which is, okay, we've already done that. We've done that a little bit with this problem. Look, B and C was domain and range. So it's not going to change a whole lot other than the fact that we're going to deal with some new things like asymptotes and other kinds of strange discontinuities, because that sets the stage for our very, very next section. But if you guys were to turn to example 1 in the notes, what's starting to happen is that you no longer have graphs. If you flip after page 2, page 3 in the notes, page 4 in the notes, there are no graphs, but yet you still will have to figure out what the domain and range are going to be. And it's a lot more challenging, so you don't want to blow it off. So the plan will be for me to do that on Monday. So we're going to be off the syllabus. We're going to be off our timeline by a day, but we've already had some ideas about how we're going to rearrange things anyway. So just kind of keep that in mind. The good news is you will not have homework over the weekend. Yay, I know you're happy. So that's kind of what the plan is. I have heard nothing about tomorrow. There's rumors about if there's any kind of change to the school day that it could be a 2-hour delay because the cold is still going to be around, but then it breaks later in the afternoon. Do not quote me on that. I will almost guarantee that we're not going to have an e-learning day all day, but it's either going to be a 2-hour delay or just a normal day. It's probably a 50-50 chance there. 50-50 chance that's not going far out on a limb, is it? All right. If anybody has any questions, I can hang around in the chat for a little bit. I do have to set up my Calculus AB Zoom session, which is going to go on at 1:30. But you are free to leave the chat and leave the Zoom session if you want. It's really easy to do. Just kind of locate a little red X and maybe hit that, or an exit feature, but you'll figure it out. But I'll stay around if people have got some questions over any of the homework. Obviously, use the discussion board if you guys need to, and help one another, and I'll monitor that. So no problem. No problem, Anthony. I'm glad to help. I would like to bring up that the 9.5 Schoology is only accepted in one submission. Nope, Blake, that was not intentional. And I'm going to tell you what, I am going to correct that right now And I'm going to reopen 9.4, Jenna, because I promised you guys that I would indeed do that. So let's make that happen. First things first, 9.5 homework is set up so that you have one chance. Yeah, make it a good one. How about we make it attempt limit unlimited? And then it's on review, it's resumable, so we're good there. So 9.5 has now been adjusted. And you know what? I'm going to let you guys watch this. How about that? I'm going to let you see all the action. Okay, and then we're going to go back into 9.4, and we're going to make this baby enabled until, how about tonight, Wednesday the 30th at 11:59. Unlimited, resumable, all that. So 9.4 and 9.5 are both open. So I'll let you guys fix those, and I won't get anything in the gradebook until tomorrow. So hopefully this helped. No problem, Abdur. Glad I could help. And Jackson, this is fun. I like doing this. And I want to tell you guys, this might be the way that we roll a lot in the future for Calc AB. I tend to want to give you guys some review sessions for calculus before a test, more robust ones. And I used to have them at school, and you could come in the evening from 6 to 8, and we just go through problems. But wow, wouldn't this be a better way to do that? You could stay at home, you could be in your pajamas, whatever. So I want you to get really comfortable with Zoom, because I'm going to make this available to you guys a lot. So hopefully that would work out good. And Trevor, I will open up 9.3 when we're done with the chat, because I know that you have to submit that. So in fact, I'll do that right now. So, and Trevor, is 9.3 the only one that you need? Because you've got 9.2 in, I believe, if I'm not mistaken. So, Kadiatu, when I get this video up and posted, and I'm hoping that it works, because what's weird is that when this records, it has to convert, and it takes an hour to convert it, and it changes it to an MP4. Schoology will not let me use MP4s for some reason, so I have to convert it again to something that Schoology will understand. Usually I do it in a WMV, a Windows media file, which plays pretty much on anything. And then I'll usually host it on my YouTube channel, only because if I host it on YouTube, it runs faster on your devices, because YouTube servers are much more robust than Schoology servers. And if I host it on YouTube, you can watch it on a mobile device. If I just host it straight up on Schoology, I don't think you can watch them on iPhones and iPads and other kinds of phones and things like that. So that's what the situation is, and it might go pretty late into the afternoon, early evening, Kadiatu, but you didn't miss a whole lot. But I'll try to get this posted before the sun goes down. So, all right. Anybody else have any questions? Okay, proud of you guys. You guys figured out Zoom very well. I thought that was going to be a little bit tougher. Didn't seem like people had questions in the discussion group about how to get on and so forth. So, Andy asks, can we not see submissions? Let me double check. You guys should still be seeing the same screen that I am. I've got my Schoology screen. 9.5 settings. Oops, you can see some people's scores there. No time limit, unlimited, random order, question review. Oh, view submission. I need that to be yes. I need that to be yes. I'm going to double check. Do I have that set up correctly in 9.4? Because now that scares me. Yeah, those were both yes. Okay, Andy, you're good now. You can see submissions. Max, you're good. Too many requests. Any other questions before we head on out? All right. Okay, looks pretty good. Looks pretty good. Just post questions in the chat, or in the sorry, the discussion board if you guys need to, and I'll be around all night tonight to monitor them. So we will not talk about four-dimensional hypercubes tonight, but that will be a conversation we'll have later on, Trev. So, all right, thanks, you guys. I probably won't see you until Monday. Then good luck on the quiz, and if you want to see me face to face to ask any questions, I will be at school all day on Friday, so you can come in the morning or come in the afternoon. So, all right, take care, keep warm, and we'll see you later.